Okay, so thanks everyone for joining us. In this talk, we'll highlight our Aquamonitrix nitrite and nitrate analyzer and the role it can play within environmental water monitoring. And specifically, we'll look at a comparison of our Aquamonitrix technology against typical commercially available UV probe technology for nitrate and nitrite analysis within surface water and estuarine water monitoring sites. So in terms of the presentation itself, and what we'll look at, we'll take a look at how our Aquamonitrix analyzer technology works, how and why is it different. We'll evaluate some of the advantages associated with the Aquamonitrix analyzer systems, and then of course we'll touch on some case studies and highlight how the analyzer technology adds value within these scenarios. So as you can see here, in terms of the analyzer system itself, we have a range of different packages available. The photos here, which are shown, the unit on the left is typically used for process control. It's more of a standard setup with a HMI. The user can interact with the system via the HMI system. It's really more for fixed point analysis. The unit on the right then is the portable analyzer, so everything is self-contained and the unit is completely portable and can be deployed remotely. In terms of the technology and the technology in which the system is based upon, the system employs rapid ion chromatography combined with our UV LED based detection technology. That enables simultaneous selective detection for both NO2 and NO3 in situ. In terms of analytical performance, really we're striving to achieve lab quality performance in the field. So we expect greater than 95% accuracy in situ and plus or minus 5% on the precision. And we also have, where the analyzer is also accredited to ISO 14034 in terms of performance in the field. If we take a look at the fluidics and just to kind of dig down a bit in a bit more detail in terms of what the system, how the system works. As I mentioned, at the core of the system, it's based upon ion chromatography. And that means we essentially use separation chemistry. So if we look at the fluidics, the system, the inlet and outlet of the system are submerged within the sample that we're analyzing. There's a small pump that draws the sample through the system. That fills a sample reservoir. We pull a sample aliquot from the sample reservoir. That fills a sample loop of a fixed volume on a six-way valve. The mobile phase then flushes through the six-way valve and the sample is introduced into the mobile phase. That all then passes through our anion exchange column and it enters into our UV LED detector. And we use a UV LED at a wavelength of 235 nanometers, and that enables our direct absorbance detection of nitrite and nitrate. And because we have that separation up front, we achieve simultaneous resolved peaks for nitrite and nitrate. And that's basically what it looks like within the system. So really, the core difference between our technology versus typical UV probes, UV devices or UV probes, they use algorithms to estimate the nitrite concentrations and measure for NO3, of course. But these probes are heavily impacted, or they can be impacted by turbidity, the presence of organics, and other interferences. But a key interference for UV probe, direct UV probe analysis, of course, is salinity and fluctuating salinity specifically. If we look at the absorption spectrum for nitrite and nitrate, using UV probes, the NO2 and NO3 absorb, the absorbance spectra for NO2 and NO3 overlap. So that means that algorithms are required to estimate the nitrite concentration. If you look at what our analyzer generates, this is a typical chromatogram which the system generates. But as you can see, because we have the separation, we achieve selective nitrite and nitrate detection in a given run. In terms of analytical performance, then for NO3, it's 0.6 all the way up to 500 milligrams per liter as NO3. For nitrite, it's 0.05 all the way up to 100 milligrams per liter as NO2. So a really broad range, and that enables the analyzer to be used within a broad range of applications, including environmental applications. On the salinity point, then, this is a real unique advantage of the system. As I mentioned, using UV probe technology or direct UV absorption, it's a big challenge to measure in fluctuating saline matrices. What we do within our system, we use an on-column matrix elimination technique. So our mobile phase or our eluent is basically dilute sodium chloride. So by using dilute sodium chloride, we overcome the interference effects of a saline matrix. And the chromatograms here just highlight the chromatogram for freshwater shown on the bottom, 20 ppt salinity shown in the middle, and on the top there you see full salinity 35 ppt. And as you can see, there's no significant difference in the chromatograms that are generated. We do see a bit of band broadening, but in terms of accuracy and performance, there's no significant difference in terms of performance. So that enables us to deploy the system in freshwater, and the salinity can change over time, and we don't need to recalibrate. The accuracy is maintained. So to summarize the key advantages and the differences of the Aquamonitrix technology versus UV probe analyzers, as I mentioned, the ion separation or chromatography combined with the patented UV LED detection that enables for selective simultaneous detection for nitrite and nitrate. The calibration aspect as well is quite unique. There's no need to recalibrate on site, so we calibrate in factory, and there's no need to recalibrate in the field or after, even if you change matrices. Because we have the separation also, we can detect accurately at low levels of NO2, even in the presence of very high levels of NO3. And then from a sample matrix point of view, as I mentioned, it's independent. So we can deploy the system in a freshwater matrix. The salinity of the sample can change over time, all the way up to fully saline, and we don't need to recalibrate the system. So it's a big advantage when considering environmental monitoring. And then, of course, there's no drift or fouling associated with the UV detection system that we use, because of course we have the separation, and we're only using a very small sample aliquot within our mobile phase. Whereas, as we know, with UV probes deployed in situ, biofouling can be a challenge. So with that being said, let's have a look at some case studies, and specifically this is a case study from a customer in Wexford in Ireland. And this particular site is an estuarine site, basically. So the saline composition of the sample changes over time in a diurnal pattern, really. So here's just some photographs of the actual deployment site itself. And as you can see, our analyzer is shown here, installed within the kiosk, but there's also a range of other commercially available probes installed within the kiosk. So in terms of physical parameters, there's a xylem exosonde measuring the physical parameters, pH, DO, turbidity, etc., which has been there for a number of years now, I believe, and it's been working exceptionally well. But the customer informed us that Xylem didn't install their UV probe within this deployment site due to the challenges associated with salinity. So that's why they contacted us. They did install an alternative commercially available UV probe in addition to our system, and we'll take a look at some of the results here now in a moment. So this was the results generated at this deployment site. as you can see from our system, there was no NO2 present, as that was what we expected at this particular site. But of course, NO3 was present, and it fluctuated over time. But for our results, shown on the bottom left here, quite a predictable pattern was observed. But when we look at the commercially available UV probe, some challenges were experienced, and really these were observed due to those fluctuating salinity challenges. So just to highlight the severe fluctuations at the latter stages of the deployment. The other location which was installed at this customer's site was in Wexford, but it was a different location. Similar setup, except low levels of salinity were observed, but high levels of turbidity were experienced. And again, here you can see a comparison of the Aquamonitrix nitrate data compared to the commercially available UV probe. This was a significantly challenging site for the UV probe. There was a number of modifications on the probe were required to generate this data. The turbidity and high levels of organics was a challenge for the probe. But again, comparison of the probe data versus our data are shown here. And finally, then, just to highlight, we also have a remote function or a deployable functionality associated with the analyzer as well. So this was an alternative customer, a different customer, and the requirement here was to deploy the analyzer upstream from a fixed point, a fixed position analyzer within a kiosk. So this was a remote deployment, and really just to highlight some results which were quite interesting. The NO3 levels were as expected. It was the data on the NO3 was comparable to what was being observed within the fixed position analyzer kiosk. But what was interesting was nitrite. Transient levels of nitrite were experienced for the remote deployed Aquamonitrix analyzer, but within the fixed position analyzer of the kiosk, no nitrite was present. And as you can see here, we were able to validate these nitrite concentrations through the evaluation of the chromatograms. And we've published all this. This was in a paper which we published last year. If you're interested, there's obviously a lot more detail within that paper. So you can feel free to check that out if you'd like to see a bit more detail on that. So that was a quick run through of some of the analyzer technology itself. The key advantages, really, it's the core advantage of the analyzer versus UV probes. It's all around the salinity aspect. We can overcome the salinity challenges, whereas UV probes, it can experience a lot of issues and challenges within those environments. So feel free to come in with any questions now, and of course, obviously get in touch as well if you'd like to go into more detail on anything after the webinar.
Well, thank you very much, Eoin. That was a really nice summary of the challenges making those kinds of measurements in those type of environments. We do have a few questions coming in. One was around the operations maintenance of the deployments. You mentioned the challenges of UV probes and cleaning and fouling. What are the challenges that were faced in the first deployment, the one where what sort of maintenance intervals were we looking at?
Yeah, silt was a big challenge within that site. So I think the customer was cleaning the probe every second week. There was a requirement to come down and flush down the probe and remove silt and so on. So it was the probes were working well for a period, and then they would start to kind of go out of control, and then they would have to take action. In terms of our analyzer, it was a relatively short deployment. It was 1 month or about a month and a half, but there was no we installed, and there was no service, significant service required during the course of that deployment.
Okay, and what was the measuring frequency is another question on that data. I mean, again, how does that compare? How often was the data produced from the Aquamonitrix?
Yeah, we were running hourly. We have the max frequency or sampling time that we can do is every 15 minutes, but we were doing hourly for this particular deployment. And of course, the probes have a higher frequency. They can generate data in a much higher frequency. So that was the difference on the frequency side.
Okay, and somebody was being very observant when you put there's a data trace. I think it was from the second deployment, and although the trends look the same, they definitely diverged at one point. The red, I think, yeah, which one? This one here.
Yeah.
Do we have any comments around that? Why is there the divergence between them?
Yeah, that was an interesting observation for us as well. So we had a good conversation with the customer on this, and one theory was turbidity, a question of turbidity, but we also had a meeting recently, a technical meeting with a UV probe manufacturer, and they had an interesting insight around the algorithm. So they said that this type of thing is what they would expect because they're using an algorithm to overcome some interferences around turbidity, and they would expect a lag like that in terms of the concentration. So that was the information that they provided. But yeah, there's definitely a difference between the probe and our analyzer in terms of us interrogating the chromatograms and also grab samples. We were where we wanted to be and expected the analyzer to be in terms of performance, you know. So the analyzer was working correctly from our side.
Okay, another couple of questions coming in. This one from Bing Chow. I hope I've said your pronunciation name correctly. My apologies if not. Asking a question around in seawater, what's the sort of can the detection limit for nitrate be done even lower? So how low could we detect nitrite in saline environments is the question.
So on the fully saline application, we lose a bit of sensitivity for NO2. Within the freshwater matrix, such as drinking water, we can get down to very, very low ppb levels, of course, but we do lose a bit of sensitivity within a 35 ppt saline matrix. So you're talking about 0.1 or just sub 0.1 milligrams per liter as NO2 for nitrite in a fully saline matrix.
Okay, so that's 0.1 as NO2.
Yeah, in fully saline. Yeah,
fully saline. So that's about 0.03 as N, something like that, give or take.
Yeah,
something like that. Okay, I hope if that's okay. And obviously, if you wanted any more information, we have full spec sheets available on the website. You can always go and look at those, or just pop us an email. We're happy to have a one-to-one meeting. A question from Oliver. It's around I think you've already touched upon this. Somebody's asked about the sample time. Oliver was asking what is the lag time of the system, which I think you've already covered. But if you want to just expand on that a little bit in terms of our response time to picking up a measurement.
So is that the question, similar question we just had a moment ago, Mike?
Sort of, yeah. For process control, what is the lag time of the system? I think we sort of said we can get down to 10 minutes, can't we, or something?
Yeah, well, the sample frequency is every 15 minutes for the portable unit, but on the process control fixed analyzer, it's every 10 minutes.
Yeah,
and that's feasible. Yeah.
Okay. So we're getting to the end of the allotted half an hour. If there are any final questions, please pop them into the Q&A. We like to keep these short and sweet to keep the attention going. So, as I said at the beginning, first of all, thank you very much for Eoin for putting the presentation together. We know how much it does because most of us have done this type of presentation. So thank you very much, Eoin. And it's a last chance for any more questions. If there aren't any, we're going to wrap up, and we're going to the presentations will be available on our website as a recording. We will be sending all attendees a link via email. And of course, if any questions pop into your mind between now and then, respond to the email. We'll be happy to either give you a call, set up a meeting, or just pop the answer into an email. So that's it, really. Happy New Year again to everybody. A little bit belated, but we'll see you at the next webinar. We run these every month, so keep an eye out for the next one in the series. And thank you very much for attending.